Hey, hello everybody. Mr. Reeves back with you yet one more time. Today we're looking at sets of real numbers. So if you're going, what is a real number? Well, pretty much any number that we're dealing with at this level is a real number. When we get to more advanced math, I should say when you get to more advanced math, because I won't be there with you. High school math, you learn about something called imaginary numbers and complex numbers. But for us at the middle school, we are working in this purple box of real numbers. And we take those real numbers and we divide them up into what we call subcategories or smaller categories. So if you take a look at what we have here, we have real numbers and we divide that up into two sections. On the left over here, we have rational numbers, and on the right, we have irrational numbers, okay? So then within the rational numbers, and this is the area you've been working in mostly, we break that down even more. You've heard us talk about integers. You've heard us talk about whole numbers, and there's a smaller category that they did not include in here, and that would be what we call counting numbers. So I'm going to go ahead and add that in. Okay, counting numbers. So, that's just hard to write. Let me write the words and then I'll just circle it. How's that? Counting numbers. Okay. So really, we kind of should work from the inside out instead of from the outside in. So let's start with counting numbers. All right, counting numbers are the numbers you first learned when you learned to count. And the smallest number that you ever learned was 1, right? So 1 would be a counting number. I'm going to go ahead and scratch that off and put 1 right here. And then it went 1 and then 2 and then 3 and then 4. Basically, you counted on your fingers, right? Anything you can count with your fingers is a counting number. Does that make sense? All right, and then we add just one single number, and then we go from counting numbers to whole numbers. And that number we add is 0. You can't count 0 on your hands, can you? I mean, I guess you can close a fist or something like that. So counting numbers plus 0 make whole numbers. And by the way, they've got this square root of 4 here. The square root of 4 is 2. All right, they just wanted to show you that some kind numbers can appear differently. I mean, I could put, say here, the square root of 16, which is 4. By the way, those would all be counting numbers as well. The only number in this whole number circle that's not in the counting number is 0. Okay, so counting numbers, anything you can count on your fingers is a counting number. Throw in 0 plus all the counting numbers and you have whole numbers. Okay, and then outside that we have integers. Integers are whole numbers and they're opposites. Okay, so what does integers add that we didn't have before? It adds negatives. But notice it's negatives or the opposite of whole numbers. There's still no fractions and still no decimals. When we add in fractions, and any fraction that can be changed to a decimal version, any fraction, let me say that again, any fraction can be changed to a decimal. So any decimal that could be changed to a fraction, we have rational numbers. All right, so again, starting with the smallest set of numbers and working our way out, anything you can count on your fingers is a counting number. Add 0 to those counting numbers, now you have whole numbers. Add the opposite of those whole numbers, and you have integers. Add in fractions and the decimal representations of fractions, and you have rational numbers. By the way, just a reminder, that line right there, that means repeating, right? So that would be 0.3333 dot, 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 dot. All right, that's a repeating fraction. Well, it's a repeating decimal. It actually comes from the fraction 1/3, right? 1/3 is equal to that. Okay, now that is this box here. So everything on this left side is a rational number. It's a type of rational number. 0 is a rational number. All right, 3 is a rational number. -1 is a rational number. A half is a rational number. Okay, anything in these blue circles is also part of this box. All right, over here outside the box we have these separate numbers. Okay, and they are called irrational numbers. Irrational, means not, right? So these really are not rational numbers. Now, how do you recognize an irrational number? One, it cannot be written as a fraction, okay? So if it's a fraction, it is rational. So these ones are not fractions. So what are they? They are decimals. They are non-terminating. What does that mean, non-terminating? That means they go on forever and ever and ever. Non-terminating and non-repeating. Non-terminating and non-repeating decimals. All right? That's what irrational numbers are. So how do you recognize them? Well, the most common one is pi. You guys know about pi, right? 3.14159 ... It goes on forever and ever and ever. Also, if you notice, these are all square roots. Now, be careful. All right, and I think that's why they put this one over here. Not every square root is irrational. All right? But what do these have in common? They are not perfect squares. So if I want some square roots that are rational, I could put like the square root of 49 because that's equal to 7, right? Or I could put the square root of 121 because that's equal to 11. By the way, this should be the square root of 49 should be in here actually if I'm going to do that, right? So should the square root, well, square root of 11 is also an integer. Here, let me do that one. I mean, did I say square root of 121? There we go. I'll put the negative out in front of it, and then it's the integer, okay? So if you're looking for an irrational number, this is what you look for, okay? You look for square roots of non-perfect numbers. Square roots, of non-perfect squares. Square roots of non-perfect squares. Now you're probably thinking, well, how do I know if it's a perfect square? Well, you kind of have to have, you really should have some memorized, okay? For example, 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square. Like all the way up to like 12 squared is 144. So anything, when you take a whole number and you square it, that result is a perfect square, right? So if I write the square root of 144, that's going to be rational because it's 12. 144 is a perfect square. If I write the square root of 9, that's going to be rational because the square root of 9 is 3. But 17 is not, right? Is square root of 16 is 4, and the square root of 25 is 5. And 17's between those. So the square root of 16 is going to be rational, and the square root of 25 is going to be rational, but the square root of 17 is not. All right? A great thing to do is just put it in your calculator. And if you put it in your calculator and it just goes on and fills the whole screen, then you know that it is irrational. Okay? So irrational numbers again. Anytime you see pi, that's the most common irrational. Later you'll learn about this number e. Again, that's a high school thing. That's a common irrational number. But look for square roots that are not perfect squares. And again, you can pull them up in your calculator. So for example, I'm going to put in the square root of, so I'm going to go ahead and go second x squared to get that square root symbol. I'm going to put in the square root, say, of 625. And I get 25, so that's rational, right? I'm going to put in the square root of 576. All right, and what do I get? I get 24. That is rational. Now I'm going to put in the square root of 15. All right, and you see that? Okay, that's your indication. That's irrational. I'm going to put in the square root of 29. Boom, irrational. All right, so I hope you can clearly see, all right, the difference. So if you have a square root, put it in the calculator, and if it comes out to be a whole number, it's rational, all right? Or a decimal that ends. By the way, because I can actually, let me make one exception here. If I do the square root, say, of 36 over 25, okay? That's not going to be a whole number, but the square root of 36 over 25 is the square root of 36 over the square root of 25, and I get 6 over 5, right? So that one is going to be what, 1 1/5, which is going to be 1.2. So if I put that in my calculator, all right, it's not going to be a whole number, but the top and the bottom are whole numbers. It's 6 over 5, and you'll notice it ends, okay? As opposed to these other ones, again, if it's filling your calculator screen, then you're going to be irrational. Okay, so just to summarize again, real numbers, any number that you are dealing with right now at your level is a real number. We break them up into two big categories. Almost every number you're ever going to encounter is going to be rational. We started off on the inside. Again, we have counting numbers, anything you count on your fingers. Add 0, now you have whole numbers. Add those negatives, now you have integers. Add fractions, and any fraction that is converted into a decimal, and you have rational numbers. All right? Irrational numbers, they're going to be, can't be written as a fraction. They're going to be decimals that go on forever and ever and ever and never repeat a pattern. Remember, this one right here goes on forever and ever and ever, but it repeats a pattern. So irrational numbers, again, are non-terminating, they never end, and non-repeating decimals. All right, so we're going to go ahead and end this video here, and then I will be making another video where I go through and work out some examples with you. All right, I hope this is helpful. Until next time.